Hey everybody, welcome to video 11-3B. Before we get into our content starting on page 604, I did want to just go over really quickly what the rules for finding the LCD, which as you guys may have heard this little acronym in math before, it stands for least common denominator. It's basically the least common multiple of any of the denominators that you encounter in an algebraic problem, okay? So to find the LCD, there are two main steps. The first step is to factor all the denominators that you currently have. And you guys, when we're talking about factors, we're talking about if it's a numerical denominator, then you want to use prime factors. So a recalling of what your prime numbers are. Remember, those are numbers that only have themselves and 1 as factors. So those would be 2, 3, 5, 7, 11, 13, and so on. Okay. When we talk about primes and prime factoring, all numbers can be broken down into a product of prime numbers, any number. Okay. So we typically use these numbers, and typically it's the first few factors. We don't get really into many high prime numbers when we're dealing with factoring numbers for our denominators in this section in our treatment of LCD within our geometric work, okay? But it's important to know that all of these factors that you see here will occur within the numbers that we are trying to find the LCD for, okay? So the first step is factor all the denominators, and don't worry, I'm going to walk you through this process when it comes to each example we're going to do here on page 604. But the second step is after you've factored the denominators, to create your LCD by taking or using every factor to the highest power that it occurs in any factored denominator. So, in case you haven't written this down anywhere, take a pause on the video and just write this two-step process down somewhere in the margin maybe, or at the bottom of page 604, and just put a big circle around it because you're definitely going to want to be familiar with the steps for finding the LCD as we go through. Okay, and I'm going to talk you through each one, but just so that you know what we're going to be doing. Okay, so let's move on to page 604 now. And on page 604, we are working with the idea of similar figures. And remember, similar figures are going to be able to have corresponding sides that are proportional. So this is the type of problem that we might see for a similar figure problem. First of all, let's look at A. A says, if we're looking at this group of figures over here, it asks us to find the value of x, and the value of x is within an angle, as you guys can see here, angle C. And we know that as we're looking at the figures, angle C corresponds to angle R, and so we know its measures are the same. So we're going to take our 4x plus 27 and set it equal to 95. and we're going to solve for x. Pretty simple. Remember that when figures are similar, corresponding angles are congruent. Then the second part of that example A is taking and looking at the ratio of the sides. So if I want to find y is within the side AB, and y is also within the side AD, both of which, this measurement here and this measurement here, are on the left figure. And so when we use them in a proportion, we just want to make sure that our labeling is consistent. Notice that it's the left over the right in this proportion. So you want to keep that consistent on the left-hand side of the equal sign and the right-hand side. So we have AB to PS, or 4y to 10, 4y to 10, is going to be equal to the same ratio as AD to PQ. AD is again, from the left figure, PQ is the corresponding side from the right figure. Now those values are 3y minus 5 and 5. So what we need to do at this point, you guys, and I'm going to zoom in a little bit so that you can see the work that we want to do off to the side here to work with our LCD, okay? What we want to do is we want to work on finding the LCD. I'm going to do that in green. So our LCD of the two denominators that exist. The denominators that exist right now are 10 and 5. So I'm going to list those just one on top of another like this. 10 has prime factors of 2 times 5. And 5 doesn't have any other factors than 1. 5 is already prime. So when I put those two denominators together to try to find my least common denominator, we need to take as our example or our two-step process that you wrote down says, we're going to create our LCD by using every factor that occurs, and so it looks like we have a 2 in existence and we have a 5 in existence, and each one of those factors only ever occurs to the degree of 1, or to the exponent of 1, okay? So all we need to do is use just 2 times 5 to create our LCD. Now I know this seems like a simplistic example, but our examples, depending on what our proportion looks like, could be more complex, and you'll see that in the next ratio that we're going to set up. Okay, so we want to make sure that we are always just following this process, and we're, as you know, have already done some more complex algebra examples. So hopefully you understand where we're at. So what we're going to do once we have our LCD, we are going to take notice and multiply the LCD on both sides of the equal sign. That is the multiplication property of equality that allows us to do that, because it's the same number we're multiplying by. And then we're going to go through and we're going to cancel out common factors. So 10 has a common factor here in the denominator and numerator of 10, and then my 5 goes into 10 twice, okay? Or we can think of how it has a 10 is the same thing as 2 times 5, so it would cancel out the 5 part of the 10 and leave a 2 behind. Clearly what you can see is that there's going to be a 2, a reminder that that 2 is times the entire quantity that's left in the numerator, so make sure you put parentheses around that. And then we're going to simplify the algebra, and we're going to get 4y equals, distributing the 2, 6y minus 10, and solving, we get that y equals 5. Let's take a look at part B of example 2. Part B of example 2 says, we've got a couple new figures here, try to get them all on the same screen. It says find the value of x. So first of all, if we look at the diagram, we can see that x is within angle M, here 5x plus 5 degrees, and M is corresponding to angle Y over here, which is 4x degrees. So we can go ahead and write that in. The measure of angle LMN is 5 times x plus 5, and that is going to correspond to 4x. So distributing 5x plus 25 is going to equal 4x, and solving, x will equal 25. Oops, actually you guys, I'm sorry. This should have been a minus sign all along. That's 5x minus 25, and so there. Now we get x is positive 25. Sorry about that. Then we're going to go over and we're going to find the value of y. Now where is y? Y is located inside JK right here. And JK is going to correspond to VW. So we're going to set up our proportion with those two values in that order. Now again, to be consistent, we've gone from the left to the right here, okay? So our proportion needs to compare two other sides that we already know the measures of, but again we want to start with the left-hand figure in the numerator, and so I think we know another value for MN, and we know a value for YZ. Okay, let's fill in what we know. So if we set up the proportion, JK is 2y minus 8 all over VW, which is 4. MN, I don't know where my Z went there, sorry. MN is 1.5, and that corresponds to YZ, which is just 1. Okay, pulling off to the side really quickly, because we only really have one denominator that is not a 1, 4 is it. So that was a pretty quick check. What we're going to do at this point is we are going to take our original proportion and we're going to multiply both sides by the least common denominator. Notice what's happening each time we do that. There's my LCD there. And here's my LCD here. I hope what you guys are seeing is consistent with what we saw on our algebra day, which is that all the time when we multiply through by our least common denominator, if we've correctly selected our least common denominator, the next step of my algebra should no longer have 1.5 times 4 is 6, should no longer have any fractions left in it. So we get y equals 7, and just wanted to let you know that this is just an application of the algebra process that we were doing. It's just that instead of being given the proportion directly, we're coming up with it, and that's what we worked on in the first video, 11.3a. So on the next page, you guys, there's just a couple of your turns that I would like for you to do. And that, of course, is numbers 8 and 9. Okay. I might suggest to you, and there is some room in the margin to do this, that as we're looking at the two triangles that are being compared here, ABE, similar to triangle ACD, that you may want to redraw the triangles so that they're no longer overlapping and that they have their corresponding vertices, that's a B, in the right spots, and then relabel the diagram. And I think what you'll see is that it'll be a little easier to set up your proportion that way. Keep in mind that this length right here, AD, is going to be the sum of the two pieces, the two segment lengths that you see there. So it'll be 5.6 plus y will be the length of that one. So just to keep that in mind as you're setting up your proportion, and I will check in with you guys tomorrow. See you later.